Hello friends, this is a lecture on hydrocarbons in your class 11. It is port level and this knowledge will apply for competitive exam. Okay, so at first we take knowledge, then on this knowledge we will give you the another lecture for competitive exam for IIT or comparable competitive exam. Okay, now what is hydrocarbon? We know from the class 10 also. The hydrocarbon is the organic compound composed of only carbon and hydrogen called hydrocarbon. So what is hydrocarbon? Hydrocarbon is the compounds containing hydrogen and carbon only. So hydrogen and carbon containing compounds are hydrocarbon. Clear? Now in this hydrocarbon we will study, in this lecture I will cover alkanes, preparation of alkanes, properties of alkanes, reaction of alkanes, and alkenes, preparation of alkenes, properties of alkenes, reaction of alkenes. Okay, now hydrocarbon were subdivided in this way that alkane, alkene, alkynes and aromatic hydrocarbons. So alkane, alkene, alkyne are aliphatic hydrocarbons. So hydrocarbon, aromatic and aliphatic. Aliphatic hydrocarbon and aromatic hydrocarbon. Now this aliphatic hydrocarbon is three types. One is alkane, alkenes or alkynes. Okay. Now alkanes, which is also known as olefin. What is olefin? Olefin, the meaning of olefin is less reactive. So alkane is very less reactive. Alkene and alkynes, this both is known as unsaturated hydrocarbon. What is this? This is unsaturated hydrocarbon and this is saturated hydrocarbon. Clear? So alkane is saturated, alkene is unsaturated, alkynes is also unsaturated. Now the general formula of alkane is CnH2n plus 2, where n is 1, 2, 3, 4, any integer. And general formula of alkene is CnH2n, and what is alkyne? CnH2n minus 2. Example, if n is 2, then what happen? C2H2 into 2 plus 2, that is actually C2H2 into 2, 4 plus 2, 6. So it is maybe C2H6, C3H8 in this way. And what is this? C2, if n is 2, then it is 4. That means double bond C, hydrogen, 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 hydrogen. Because all carbon contains at least 4 bond. Okay, this is the hydrocarbon, alkene hydrocarbon. This is unsaturated. What is unsaturation? Unsaturation means double bond or triple bond, carbon carbon double bond or triple bond, or carbon carbon oxygen double bond triple bond, anything. That's mean there is a pi bond. Okay, if pi bond containing compound is there, which is actually unsaturated. So there is a sigma bond, pi bond. So carbon carbon, there is a double bond, and what is this? C2 is 2 into 2, that is 4 minus 2, that is 2. So we can write in this way, C triple bond C. Okay, so this is also unsaturated because there is a sigma bond and pi bond, both are there. So what happened? That's mean hydrocarbon is aliphatic and aromatic. Now in aliphatic hydrocarbon there is a alkane, alkene and alkyne, and aromatic there is another types of hydrocarbon which have a characteristic order and which have some character which is actually aromatic. There are so many characters in this type of compound. I will give you a separate lecture on aromatic compound. Okay. So now I will discuss as first alkane and alkene, and the next lecture I will cover alkynes and its preparation and aromatic hydrocarbon. Okay, according to your syllabus, latest syllabus. Okay, now alkanes, how we can prepare alkanes? That's when you know methane, ethane, propane, all are hydrocarbon. Yes, pentane, hexane, heptane, octane, nonane, decane, monodecane, dodecane, in this way. So there are so many hydrocarbon, but how we can prepare hydrocarbon? Okay, so at first we have some method. The first one is that by hydrogenation of alkene, number one, by hydrogenation of alkene. Clear? By hydrogenation of alkene. Then what happened? If this is alkene, then we can hydrogenation on it, like hydrogen in presence of nickel, 350 degree centigrade temperature. Okay, then this hydrogen can add to this compound. Arthat addition of hydrogen in presence of nickel catalyst at minimum 350 degree centigrade temperature, then we can get CH3. It may be in this way, CH3, CH double bond CH2, also hydrogen, nickel, 350 degree centigrade temperature, we can get CH3, CH2, CH3. So this is the addition of hydrogen. Okay, this is the addition of hydrogen. So from the ethene we can get ethane, from the propene we can get propane, no problem. Now reduction of alkyl halide. What is this? Reduction of alkyl halide. Number two, reduction of alkyl halide. What is alkyl halide? That means there is a R group and there is a halogen. It may be CH3 Cl, no problem. Alkyl group, halogen, halide. So alkyl halide. The value of R, it may be CH3, CH2, Cl, no problem. This is maybe R, this is maybe R. So R may be changed. This is alkyl group. So in general reaction, this is. So how we can get the alkane from the alkyl halide? We can use sodium metal. Okay, we can use sodium metal. Clear? And in ether medium, the medium is ether, which is actually known as Wurtz reaction. What is this? Wurtz reaction. What is Wurtz reaction? In Wurtz reaction, by Wurtz reaction, alkyl halide reacts with sodium metal in presence of or in the presence of ether medium. Ether is a solvent. Okay. Now we can get R. That's mean double number containing hydrocarbon. If it is CH3 Cl, then we will get CH3. That is, there is a single methyl. There is a methyl. That's mean sodium chloride, 2 sodium chloride. That is 2 sodium chloride will form here plus 2 NaCl. But since this is the inorganic product, we will not count in this reaction. Okay? Because this is not a balanced equation. In organic chemistry, if we do not balance it, there is no problem. Okay? So this is very important. So how this reaction occur in this way? That is actually X is sodium XR. Yes. So this is sodium halide. This is sodium halide. Then it will be R and R will be joined here. So this is the formation of alkane, the higher alkane. Okay. Higher alkane means if there is a 1 R, that there is a 2 R. Okay. So this compound contains double carbon from the former one. Okay. So this reaction is known as Wurtz reaction. Now from the Wurtz reaction, can say that CH3 Cl Na Cl CH3, then we will get CH3, no problem. But if we do that CH3 CH2 Cl, then 2 sodium, then we will get CH3 CH2, then again CH2 CH3, double containing. This is R. So this is R, this is another R. Okay, no problem. But if we use in this way CH3 CH2Cl Na Cl CH3, then this is a 1 R, this is the another R. So this R and this R is not equal, then we can write this is R dash and this is R, no problem. Then we should get R dash R. We should. That's mean actually we should CH3 should get CH3 CH2 CH3. But is it true? Always? No. Because we can see that there is a possibility, because if Cl CH3 and Cl CH3, two Cl CH3, if they combine in presence of sodium in ether medium, then we will get CH3. Again, this compound can combine to each other if two CH3 CH2Cl in presence of sodium in dry ether, then we will get CH3 CH2 CH2 CH3. Yes. So from this portion we can get this, from this portion we can get this. Again, if they combine to each other, then we can get this. So in the reaction between ethyl chloride and methyl chloride in presence of sodium in dry ether, we can get mixture of product. That's mean ethane, propane and butane. What is this? Ethane, propane and this is butane. Clear? So we can get a mixture of product. So to prepare the even number of carbon containing alkane, there is no problem to use the Woods reaction, because always if it is Rx, then we will get R, no problem. But if we use Rx plus R dash X, then there is a problem. That means it may be RR, it may be R dash, it may be R dash. Okay. So there is no guarantee it will gives R dash. So this reaction is a limited, because we are unable to get only single product. We will get a mixture of product by the Woods reaction if R and R dash is different. Okay, if R and R dash is same, there is no problem. So how we can get odd number containing alkane? That's mean if we want to say CH3 CH2 Cl CH3, from here CH3 CH2 CH3, is it possible to get by single reaction? No. By Woods reaction it is not possible. So we need different types of reaction to get odd number containing hydrocarbon, which may be core house synthesis. Okay, core house synthesis. What is core house synthesis? If it is Rx in presence of lithium, we can get RLi. Okay, now this RLi can react with copper iodide, then we can get R2CuLi. Okay, and one LiI will leave out. Okay, there is no problem. Now this R2CuLi can react with R dash X, then we can get R dash. Okay, R dash, we can get R dash and RCu. CuLi, no problem. Okay, this is part is not important, but we need this type of reaction because this is known as Core-House synthesis. So from the Core-House synthesis we can get R dash. That's mean if R is CH3 and R dash, that's mean if it is CH3, then CH3 that is 2 CH3, okay, 2 CH3, this is Cu Li plus this is R dash, that's difference from the CH3, CH2 maybe, no problem, X. Then what happen? We can get CH3 that is R, then this is R dash that is CH2 CH3. So we can get propane from the methyl iodide and ethyl iodide, or methyl chloride, or methyl halide, ethyl halide. Okay, we can get propane. So this is very important. The odd number containing hydrocarbon we can prepare by Core-House synthesis from the alkyl halide, but not from the Woods reaction. Okay. Now there are so many processes to prepare alkane, but according to our syllabus we will give a limited amount or give limited number of preparation method. Decarboxylation. What is decarboxylation? That is number 3, I think. It is number 4. Okay. Decarboxylation. What is decarboxylation? Now, RCOO this is carboxylic acid group. Now, in presence of sodium hydroxide and calcium oxide, this calcium oxide plus sodium hydroxide, which is known as soda lime, calcium oxide plus sodium hydroxide, which is actually known as soda lime. Okay, calcium oxide plus sodium hydroxide, which is known as soda lime. In presence of soda lime heat, this acid, that's mean this carbon dioxide will be removed. A decarboxylation, that's mean this will be removed. So RH is the product. So in this way we can readily get, let us consider CH3COOH from here, soda lime heat, that's mean calcium oxide plus sodium hydroxide heat, we will get CH3H. CH3H means CH4. Okay. Now if we use CH3 CH2, that is propanoic acid, then if this is removed, then we will get CH3 CH2 and H, that's means CH3. Okay. So from the propanoic acid you can get ethane. If it is butanoic acid, CH3 CH2 CH2 COOH, then soda lime heat we will get CH3 CH2 CH3. So this is the decarboxylation reaction to prepare hydrocarbon, that's mean only alkane. Okay. So number 5 Kolbe reaction. Number 5 is Kolbe reaction. By the Kolbe reaction we can get also hydrocarbon, that's mean alkane. And what is the Kolbe reaction? Actually Kolbe electrolysis. At first we take acid salt, acid, that is acid. Then if this hydrogen is removed, if it is sodium, then this is acid salt. So from this acid salt, if we hydrolyze, and that's when electrolyze, not hydrolyze, electrolysis. Okay, after electrolysis we'll get R, okay, and hydrogen will be removed from here, electrolysis. After electrolysis we get sodium hydroxide plus hydrogen, okay. So mainly this product is important. So if we use in presence of R, it is CH3, after electrolysis we will get CH3, okay. This is known as Kolbe electrolysis process. This is all are running alkane. Now there is another reaction, number 6, Clemenson reduction. Clemenson reduction. What is Clemenson reduction? Clemenson reduction is that if R, C double bond O, H or R, C double bond O, R, this type of compound, in presence of zinc amalgam. What is zinc amalgam? Zinc, mercury, togetherly known as zinc amalgam. Clear? In presence of concentrated HCl. What is this? In presence of concentrated HCl, it will reduce and it gives hydrogen. This hydrogenation occur and oxygen will be removed. That is reduction actually. And from here, zinc amalgam, concentrated HCl, then we will get R, CH2, R. Clear? Oxygen will remove and hydrogen addition. So this is known as Clemenson reduction. In real example, that's been CH3, C double bond O, CH3. Then in presence of zinc amalgam, concentrated HCl, then what happened? CH3, that will be CH2 and then CH3. Okay? From the acetone, this is acetone. So from the acetone we can get propane, or this is also known as propanone. So from the propanone we can get propane. And by the reduction of HI in presence of red phosphorus, that's been from aldehyde or acid or any types of ketone, that's been R, CHO, in presence of red phosphorus and HI will get RCH3. Okay? So this is a very important reaction also. In presence of red phosphorus HI, we can get propane. So now this is preparation is complete. Now properties. In this properties we will see physical properties and chemical properties. So what will be the physical properties? Due to the presence of weak van der Waals force, the first 4 members, that's mean up to C1 to C4, that's mean CH3, CH2 or CH4, CH3, this member, CH3, CH2, CH2, CH3, okay, or CH3, CH2, CH3. This is 3 member chain, this is 4 member, this is 2 member, 1 member, carbon 1 to 4 are gaseous. Then from 5 to 17 they are liquid, that's mean kerosene, petrol, diesel, etc. And for this reason this hydrocarbon chapter is very important, because we need kerosene, we need petrol, diesel, gasoline, grease, mobiles, naphtha, aromatic hydrocarbon, benzene, so many things, aroma. So for this reason the hydrocarbon is very important. So physical property, what is the physical property? Due to the presence of very weak van der Waals forces, from carbon 1 to carbon 4 member chain is gaseous, higher than 4, that's in 5, carbon 5 to 7 number 17, up to 17 they are liquid, and greater than 17 number containing hydrocarbon is solid. Okay, all alkanes are covalent in nature, they contains covalent bond, okay, and they are colorless and does not dissolve in water, but it can dissolve in nonpolar solvent. And boiling point, this is very important, you must remember it. The boiling point of alkanes with increase in with the molecular mass, that's mean boiling point of methane, and boiling point means if it is liquid then it will boiling point, that's mean if CH3, CH2, 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 CH3, if it is liquid CH3, CH2, 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 CH3, this is 5 member chain, this is 6 member chain. Now the boiling point of this 6 member chain will be higher than 5 member chain due to their molecular weight. Okay, so increasing their molecular weight, the boiling point will be increased. For the same alkane, the boiling point also decreases with branching. If this and if this CH3, CH2, CH, CH3, CH2, 1, 2, 3, 4, 5. Now this is 6 member compound, this is also 6 member compound, but this one has higher boiling point because there is a branch chain. So it is very important from the physical property, that's if branching is arise for the same molecule, then it will be lower boiling point, the boiling point decreases. Okay, and alkane with the even number of atoms, higher melting point also. If the number of carbon atoms is even in a chain, then melting point will be higher than the odd number, because odd number carbon containing hydrocarbon is less symmetric. For the symmetry, even number carbon containing compound will be more stable and it contains higher melting points. Okay, so higher melting point will be arise. And what will be the chemical property of the alkane? At first chemical property of alkane, it may be R H. In this way you can define, that means CH3H, that's a methane, CH3CH2H, that is ethane, no problem. Now chemical reaction, that's mean at first we can say halogenation. First one is halogenation. What is halogenation? If halogen is added to the hydrocarbon replacing hydrogen, that's mean if it is methane, then in presence of sunlight, that's mean diffuse sunlight H nu, we can get CH3Cl. That's mean one hydrogen is removed by replaced by hydrogen chlorine, that's HCl is there, okay, in the balanced equation. If we don't balance, there is no problem, but it is a chain reaction. Then again Cl2 H nu, then CH2 Cl2 again. In this way there is a, if you give 2 Cl2, then Cl4 will be formed. This is the same reaction, okay. So halogenation can be occur in the alkane in this way, and complex formation may be occur also. Organometallic compound may be formed. And number 2, I can say combustion reaction. Number 2, combustion. What is combustion? There is a complete combustion and incomplete combustion, partial combustion. It is complete combustion, then carbon containing compound, that is if it is methane or anything, that's mean CnH2n plus 2. In this way you can write, no problem, okay. Then what happen? If it is methane, then in presence of oxygen it can burn and you can get carbon dioxide plus water for complete combustion, okay. And if we want to balance, then what happen? This is very important, because if we use this type of reaction, then it will be 3n plus 1 plus 3n plus 1 divided by 2 oxygen. It will gives us that the n number of carbon dioxide, n number of carbon dioxide plus n plus 1 number of oxygen, water, n plus 1 water, okay. This is the balanced equation. Now if we use this, then what happen? Carbon dioxide, okay. And if we use that, if it is incomplete combustion, that's mean if methane plus oxygen, okay, for incomplete combustion, then what happen here? Then we will get from here carbon plus water, okay, carbon plus water. This is incomplete combustion, okay. And for complete combustion, this type of reaction may be occur. This is very important for mole concept chapter, okay. Otherwise this is not so important. But now catalytic oxidation. What is this? Catalytic oxidation. That's mean we will use catalyst that let this in presence of oxygen, okay. Then we can get that HCHO. What is this? This is formaldehyde. Now how we can get? In presence of manganese dioxide or molybdenum oxide, okay, molybdenum oxide. So in this way we can get catalytic oxidation. This is known as catalytic oxidation because in presence of catalyst, if we use copper tube, red hot copper tube, okay, then methane plus oxygen can combine to form methanol, okay. This is also catalytic oxidation because copper is catalyst here, okay. Then catalytic oxidation, in this way we can get different types of molecules, and this is oxidized molecule, no problem. Now isomerism may occur. Isomerism, what happened? If we use, let us consider that is CH3, CH2, CH2, CH3. What is this? This is propane. So isomerization reaction means if we use some catalyst here, okay, that is anhydrous. If we use anhydrous AlCl3 in presence of HCl, anhydrous AlCl3 in presence of HCl, then we can get CH3, CH3. So what is this? This is 2-methyl, this is 2 position, 1 position, 2 position, 3 position, to 2-methyl propane. 2-methyl propane. And what is this? Butane. Okay. So from the butane we can get 2-methyl propane after isomerization reaction. Okay, in presence of anhydrous AlCl3, HCl. This butane can isomerize to give propane, 2-methyl propane. Okay. Now aromatization reaction. There are so many reactions in aromatization. What happens? From the aliphatic compound we can get also aromatic compound. Now let us say CH3, CH2, 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 1, 2, 3, 4, 5, that is CH3. Then what happens? In the presence of that's mean high heat and vanadium pentoxide or chromium oxide, okay, that is in presence of chromium oxide or Cr2O3 or vanadium pentoxide or aluminium oxide, okay, and high heat about 770 Kelvin, okay, in this type of temperature, this cyclization occur. That's mean we will get CH2, 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 H2. Then it readily convert just CH, that's mean there is a double bond, which is known as benzene. So this is aromatic compound, this is aliphatic, this is aromatic. So I will show you the aromatic compound and the characteristic of aromatic compound. There is one lecture in YouTube. Please subscribe this channel and get the lecture, and which is very important for your competitive exam. On aromatic there is a full lecture. Okay, so this type of reaction is known as cyclization reaction, okay, or aromatization reaction as well as cyclization reaction. Okay. Now reaction on steam. In presence of steam, okay, in presence of steam, methane with the catalyst of nickel, it will give water gas. That's mean carbon monoxide plus hydrogen. Okay. And pyrolysis is also a reaction. Pyrolysis reaction, that's mean higher alkane, from the higher alkane we can get lower alkane also. Pyrolysis means cracking. Okay, pyrolysis means cracking. That is CH3, CH2, 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 CH3. Long chain compound. Then from this compound we can get different crack, that means just crack. Then you can get CH3, CH2, like CH2, then it may be CH double bond CH2, that is 1 2 3 4, then 1 2 3 4 plus CH2 double bond CH2, like this, no problem. So higher alkane, from the higher alkane we can get lower alkene, or also can get lower alkane, no problem. Okay, we can get also, no, this can hydrogenation, this can be hydrogenation, no problem. Okay, now I am skipping the conformation and configuration, that's mean in stereochemistry. In stereochemistry I already covered a lecture on stereochemistry. I already give a lecture on stereochemistry, and alkane gives sometimes of conformation, configuration of ethane, methane. Okay, no problem. And now that was the reaction is complete. Now alkenes. What is alkenes? I already discussed about the general formula of alkene, CnH2n. That's mean if n is 2, then what happened? C2H4, that is C double bond C H. Ethylene, it may be ethylene. This is called ethylene, no problem, or ethene. Okay, so this is actually general formula of alkene. Now how you can prepare alkene? And it is sp2 hybridized. Okay, all in alkene the carbon at least have sp2 hybridization. Okay, now how we can prepare alkene? Now from the preparation, of alkene. Okay, what is the preparation of alkene? And number one, we can get alkene from the haloalkane or alcohol. That's mean from haloalkane. What is this? Let us consider CH3, CH2, Cl. Now from here, if we can remove one H from here and Cl here, then we can get CH2 double bond CH2 plus HCl. Now how we can remove HCl? HCl, you already know, HCl is a acid. Okay, so this type of acid we remove by using a base. Okay, by using a base, but alcoholic base, that is alcoholic KOH, not aqueous KOH, because in aqueous KOH what happened here? CH3 CH2 Cl, if we use aqueous KOH, that's mean completely separated, that is OH minus, this OH minus will attack here and Cl will be removed. That's mean we will get CH3 CH2 OH, that is alcohol. Okay, alcohol. So by using aqueous KOH with the alkyl halide, we will get alcohol, but in presence of alcoholic KOH we will get alkene. Okay, so from the haloalkane we can get alkene. That's mean so many reaction is there. That's mean in this way, that is hydrogen, that is CH2Cl, then this can be removed by using alcoholic KOH, that is CH2 double bond CH2. Okay, in this way you can get double bonded compound. Let us consider CH3 CH2 Cl. Then also we can get CH3 CH double bond CH2. This HCl can remove by alcoholic KOH. Clear? Now how we can get preparation alkene number 2 from alcohol. Okay, from alcohol. How we can get? From alcohol, that's when if we see that CH2H, that is CH3, CH2OH, then if we can remove this water from the alcohol, then we can get double bond. That's mean we can get CH2 double bond CH2. Okay. So how we can remove this water? We can use the dehydrating agent. That's been concentrated. Mainly we can use concentrated H2SO4. Okay. Mainly we can use concentrated H2SO4. So by using concentrated H2SO4, water can be removed from the alcohol. If we take another example, CH3, CH2, CH OH, that is CH3. Then this OH can take hydrogen from here. That is, there is 2 hydrogen, then 1 hydrogen can this way. Then we will get CH3, CH, double bond, CH, CH3. Sorry. Now, why this OH is not taking hydrogen from here? Okay. If this hydrogen is not taken from here, if the hydrogen was taken from here, then what will be the compound? CH3, this will be CH2, this is CH double bond CH2. But this is the major product. Why it is minor product? There is some rule. Okay, there are some rule. The more substituted product, that's mean double bonded carbon containing CH3, that is substituted group. There is only substituted group with this carbon, but there is no substituted group. That's mean there is no R group or CH3 group or C2H5 like this. Okay. So in this compound, double bonded carbon containing only one group C2H5, but here double bonded, there is a one double bonded carbon, another double bonded carbon. So 2 double bonded carbon, there is a 2 group, and this 2 group stabilize this compound. That's mean you must remember in the previous lecture, my previous lecture, that's mean mechanism of the organic reaction. Okay, it must flow, but here we can say that more substituted product will be preferable according to Sedgwick rule. Okay. So in this way, after removing water or using dehydrating agent, or after removing of alkyl halide, from the alkyl halide you can remove HCl or HX to get alkene. Okay. If we use that zinc in methanol or ethanol, then also alkyl halide. From the alkyl halide, X may be removed, no problem. So in this way we can get alkene. And from the alkyne, we can get alkene. What happened? Let us consider that R, C, triple bond, C, R. Okay, this is an alkyne, triple bonded compound. Okay, if we use from here, we can get this type of compound. sorry, R C double bond R H H, or we can also get R C double bond C R H H. Okay, how? This is known as the R group, the same group in the same side of the double bond, which is known as cis. The same group or similar group, if remains in the same side of the double bond, is known as cis compound, and the same or similar group, if remains in the opposite side of the double bond, then it is known as trans compound. Okay, or EZ, no problem, or cis or trans, or that is Z compound and E compound. Okay, EZ nomenclature or cis trans nomenclature. EZ or cis trans, what is this? Cis or Z compound is that the same group or similar group remains in the same side of the double bonded compound, and same or similar group remains in the opposite side. Okay, so how we can get? This is very important. This is the trans compound. Now this trans compound we can get from the alkyne in presence of liquid ammonia sodium. That means sodium in liquid ammonia. And temperature, there is a temperature, is very low temperature. That's mean 196 to 200 Kelvin temperature. This is low temperature. Okay, very important. And this reaction is known as Bart's reduction. Which is this? Bart's reduction. Clear? This is very important. There is no T. Bart's reduction. Very important, because we don't know what happened here. It may be cis alkene or trans alkene, but when we use sodium in liquid ammonia and in this temperature range, it will give trans product, which is known as Bart's reduction. And what is this? And this is not the same condition. This is lead in barium sulfate. Palladium PD. Palladium in barium sulfate. Barium sulfate in sulfur or quinoline solution. Okay, this is hydrogenation. Hydrogen, palladium, barium sulfate in quinoline. Okay, quinoline. Clear? So this is known as Lindlar catalyst. What is this? Lindlar reaction or Lindlar catalyst. This is Lindlar catalyst. Very important, because if we want to reduce this type of compound by lithium aluminum hydride or hydrogenation in presence of nickel, then 350 degree centigrade temperature, then we will get RCH2 CH2 CHR. This is R. Okay, we will get this RCH2 CH2 R. We will not get this type of compound, but in the presence of sodium in liquid ammonia in this temperature range, which is known as Bart's reduction, will get trans product, and in presence of Lindlar catalyst, that is palladium, barium sulfate, hydrogen in quinoline, we will get cis product. Very important. Okay. In this way, so many reactions are there. This is actually preparation of alkene, and what is the properties? There are physical properties and chemical properties also. Physical properties, the first 3 members are gaseous and next 4 are liquid, and higher alkenes are solid. Okay, all alkenes are colorless, odorless except ethene. Ethene have some sweet smell. Okay, and boiling point of alkenes increases with the increase of size and have higher boiling point. The straight chain always have higher boiling point than branch chain like alkenes. And what is the chemical property? So many chemical properties are there. Chemical properties. Is of alkenes. What is this? First of all, it gives addition reaction. Alkenes, it gives addition reaction. That's mean if any alkene, that's mean if CH2 double bond CH2, if hydrogenation is occur in presence of 350 degree centigrade temperature, will get CH3. So this is the addition reaction, hydrogenation, or any types of addition reaction. If it is polar compound, then we can get CH3, CH2Cl. So H and Cl is add here, and there are so many hydrogenation or hydration. We can use also hydration reaction. Hydration means addition of water, no problem. In presence of sulfuric acid, that's mean in presence of dilute sulfuric acid, not concentrated. In presence of dilute sulfuric acid, that is, if it is C, it is R double bond R. Then in presence of sulfuric acid dilute, then we can get R, C, H, R, C, OH, R. Okay. So addition of water. So in this way we can get alcohol also. Okay. Now what happened? There are so many addition, and one addition is very important, which maintain a Markovnikov rule. For asymmetric alkene, if this is CH3 CH double bond CH2, if we want to add HBr to this compound, then we can get CH3 CH. Now this Br and H, which one will add to which carbon? The product actually will be Br CH3. But why not? CH3 CH2 Br. If Br add to this carbon and H to this carbon, then the product will be this. And if Br with this carbon and hydrogen is with this carbon, then product will be this. But this is the major and this is the minor. Now why? So according to Markovnikov rule, there is a spelling Markovnikov or Markovnikov VE also is there. Sometimes some books write Markovnikov or Markovnikov. Okay, no problem. So according to Markovnikov rule, what happened? addition of HBr or polar compound to the asymmetric alkene, this is asymmetric alkene, sorry, CH2, asymmetric alkene. Why it is not, why it is asymmetric? Because we can't equally divide this. There is a double bond, but there is no double bond. So this is asymmetric alkene. So addition of asymmetric polar compound, the negative part will be attached where less number of hydrogen present in the double bond compound. Okay, double bonded carbon is 1 and 2, first carbon, second carbon. Now in first carbon hydrogen will be attached because this carbon contains 2 hydrogen and this carbon contains 1 hydrogen. So according to Markovnikov rule, the positive part will be attached to the carbon atom which contains more number of hydrogen, and negative part of the polar compound will be attached to the carbon atom which contains less number of hydrogen. So for the addition of polar compound to the asymmetric alkene, the negative part will be attached to the carbon atom which have less number of hydrogen. So this is actually less number of hydrogen is there. So bromine will be attached here and hydrogen will be attached here. So this is according to Markovnikov rule. And there is also anti-Markovnikov rule in presence of peroxide. It may be H2O2, it may be sodium peroxide, it may be barium peroxide, or any types of peroxide or per acid also. The reaction will be opposite. That's mean here bromine will be attached and here hydrogen will be attached. In presence of peroxide, HBr, addition of HBr will be opposite. But if it is HCl, in presence of H2O2, it does not follow anti-Markovnikov rule. It will be this. Okay. So only HBr maintain the Markovnikov rule and also anti-Markovnikov rule. And for any other compound, addition of any other compound, always maintain Markovnikov rule. Okay. Clear? And what is the polymerization reaction? Ethene, that is ethene double bond CH2, it can polymerize. But n number of ethene can form CH2 single bond CH2 n. This is known as polymerization reaction. In high pressure and temperature, in presence of catalyst, that is in high pressure, temperature and presence of catalyst, ethene can polymerize. How? I am showing you. Ethene, there is a hydrogen, hydrogen, ethene, hydrogen, ethene, hydrogen, in this way. Okay, so many ethenes are there. Now if this bond is break in this way, that homolytic fission, that is dot, if it is separated in this way, dot, if it is dot, then this dot, if bonded to is this dot with this dot, then there is a hand empty, this is hand, okay, this carbon CH2, 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 and this carbon CH2 dot but hand. So in this way, so many CH2, that means CH2 hand, there is a n number of CH2, that was the ethene, now it is polyethene. So in this way polymerization takes place for alkene, then we can get so many polymers also. So the lecture will be continue to the next lecture. To get this next lecture, please subscribe this channel, and I will give you whole supports in your total syllabus. Thank you.